What we'll do here is take those steps for solving linear equations and use it to solve for a specific variable. So in each of these cases, we have a formula, and what we can do is solve for different variables within that formula. So if we have the fact that x times y is equal to r, and they're telling us we want to solve for y, what I want to do is focus on, I want to get y alone on one side of the equation. So right now it's being multiplied by x, and I want to undo that multiplication, which we can always undo multiplication with division. So if I divide both sides by x, that would get me y alone on one side of the equation, because those will just turn into a 1, and then I would be left with r divided by x. Especially when there are lots of variables, I find this kind of highlighting or having some sort of color pen to really emphasize what's the variable you're solving for can really help, so that you can focus on, okay, that's the piece we want to have alone on one side, and then it's just a matter of moving everything away from it. Okay, this next one, we have p equals 2l plus 3w, and we are going to solve for w. So again, I'm going to highlight, I want w all alone on one side of the equation. Now, with these, it's kind of like opposite order of operations, where we would usually like do multiplication, division, and then addition, subtraction. This kind of goes reverse. Like, I wouldn't want to divide by 3 yet, because it's going to make lots of messy fractions everywhere. So I want to save that division of 3 for last. Instead, what I want to focus on is that we are adding that 2l next to it. So to get rid of that 2l, I want to subtract 2l from both sides. And that would give me p minus 2l on the left-hand side, and then we'd have 3w on the right-hand side. Now I'll divide by 3, and that'll get w completely alone on one side of the equation. So that'll give me w equals p minus 2l all over 3. All right, x equals 2 times capital A plus little a. Now, in terms of variables, I talked about how like terms would have the same variable. In math, capital and lowercase represent different things. Like this might represent an area, and this might represent a length or something. So we cannot combine these together. They used different capitalizations for a reason, so we want to keep those separate. Then what we want to pay attention to is that they want us to solve for little a, so we want to make sure that that's the one that we're solving for. So we want to move everything away from little a there. A few ways to go about this. We could go ahead and distribute that 2 if we wanted to, or if we wanted to move that 2 away at this point, it wouldn't be too bad in terms of creating fractions. So let's go ahead and divide 2 from both sides. So that would leave me with x over 2 is equal to capital A plus little a. And then what we could do is subtract capital A from both sides. So we would have little a equals x divided by 2 minus capital A. So the difference is, in that first equation, I didn't have parentheses, so it wasn't as nice to divide away that 3 early on. With this case, with the parentheses, it makes it pretty nice to just go ahead and take care of that division. Because what we would end up doing is like distributing, then subtracting, then divide. You'd kind of be repeating some steps, which isn't terrible. It's just a little more convenient this way. All right, we have 1 over p plus 1 over q equals 1 over f, and we want to solve for f. So we have lots of fractions here. And what I'm going to go ahead and do is a regular find our least common denominator, which in this case would be multiplication of p times q times f. So that's what I'm going to do, is I'm going to multiply everything by p times q times f, p times q times f, p times q times f. And we should get some nice cancellations here, so that that first term, the p's cancel out, so we would just have q and f on one side. plus q's cancel out, so we would just have p and f on that one, equals f's cancel out, so we just have p and q. Okay, so now my variable is showing up in two spots. And what we want to do here is, first off, if they weren't on the same side of the equation, we'd want to put them on the same side of the equation. That's already done for us here, but just for the case of other scenarios in the future you might see, you'd want to do that movement of get everything with that variable that you want on one side of the equation. Because when we do that, what we can do is factor out. So what we can do is we're just reversing the distributive property. It's like we're taking f out of everything, and in parentheses we have our leftovers of q plus p. So we just reversed the distributive property by getting that common factor of f out of there, and then we have q plus p left over equals p times q. And why this is really nice is because if we're solving for f, now we can just divide away that q plus p expression. So divide by q plus p. So we're going to end up with f equals p times q over q plus p. And there's nothing we can cancel there. We'll talk about cancellation when we get to rational expressions and equations. At this point, that is stuck just like that. All right, one more scenario here. We have v equals pi r squared times h, and we want to solve for r. Okay, so again, we're kind of doing reverse PEMDAS, so I don't want to do anything with the exponent yet. Instead, okay, there's no addition, subtraction, but there is multiplication and division to take care of because r squared is being multiplied by pi and h. So I'm going to do is divide out pi times h. Pi times h. So we're getting r squared is equal to v divided by pi times h. Because on that right-hand side, the pi is canceled out, h is canceled out. All right, so if we have an exponent of 2, what we could do to undo that exponent of 2 is to square root both sides. So the square root and that exponent of 2 just cancel out, so we would be left with r. Now our rule is, if we ever take the square root of both sides of the equation, we should always have plus or minus. So we'd have plus or minus the square root of v over pi h. Something to think of here is with formula, like this right here is the formula for the volume of a cylinder, and r is representing the radius of that cylinder. It should be positive in this case. So if we're dealing with a real world scenario, we might get rid of that just because based on it being a cylinder, it would have to be positive. But just for the sake of kind of making sure we get this down for when we don't have a real world scenario, we should always have plus or minus whenever we take the square root of both sides. So with those, we're just using our steps for solving equations, is just focusing on a single variable and moving everything away from it.